Right, the clock has ticked over to 9 o'clock. Welcome aboard, everyone, to the GSE UK conference, virtual variety for winter of 2023. We'll be back in person in November, but here we have some more sessions to whet your appetite for that in-person conference. So here we are kicking off the DB2 stream. And the first session up is UTS Migrations with Jorn Tyson from Rocket. And without further ado, I think we're ready to go, Jorn. So I'll hand over to your good self.
Yeah, thank you. Yeah, Jorn Tyson from Rocket Software. I started my career in mainframe more than 20 years ago. As a developer, I've been an application DBA architect, and more recently, I'm a DB2 tools product specialist with Rocket Software. But today's topic is around tablespace migration, UTS migrations. My focus will be on the recent enhancement and best practices, but I will do like a full coverage, but very briefly, so you have the complete picture for that as well. So first, I'll just briefly mention what are the possible table spaces, and then we'll discuss some of the challenges related to tablespace types and why you want to migrate from one to the other. Then we will look at some of the migration scenarios, and they're basically like two categories. One of the reasons why you might want to move tablespace types is you're moving from a deprecated tablespace type to a more strategic one. And there are variations of that. For many years, we had been able to migrate from the symbol, the single table segmented, and the classic partitions to UTS. More recently, it's now possible to migrate from multi-table segmented tablespaces to PBGs. So I'll focus a bit on that today. Then another reason why you want to migrate from one tablespace type to another is that you, for whatever reason, made a wrong choice originally. So maybe you want to move from a PBR to a PBG, or you want to move from one PBG to another PBG. For instance, you might want to change the partitioning key, or you want to move from absolute page numbering to relative page numbering. I'll talk a bit about these, and then finally, you might have started out with a PBG, then it has grown to a unreasonable size, and now you want to move it to a PBR, and that has recently become available with DB2 version 13. As I go along, I'll talk a bit about the materializing reorg and some best practices and some optimizations you can do for the materializing reorgs. And by the way, if you have any questions, please jump in and ask as I go along. So a brief history of table spaces. There's a simple table space type. It was deprecated a long time ago, and it's difficult to create these today. Then there was a segmented table spaces where you have one or more tables in a single table space. They were deprecated in version 12, function level 504. So they are deprecated now. The same is true for the classic partitions, the classic partition table spaces. They were also deprecated in 504. So all of these are deprecated, which leaves us with the universal table space. So that's the strategic table space type. Obviously, all the others are deprecated. Most of them were introduced in DB2 version 9, so a long time ago. There are three variants, I would say. There's the PBG and PBR with absolute page numbering that was introduced in version 9. Then more recently in DB2 version 12, we have the PBR with relative page numbering that was came with version 12. The relative page numbering has some advantages. First, you can have pretty large table space types, so they can grow to 4 petabytes. You can have quite many rows in those tables. So I'm not saying that you won't run out of space at some point in time, but it'll probably take a couple of years before you reach tables of that size. One of the nice advantages of the RPN is that you can set the DS size at the partition level So if you're close to running out of space in a partition, you can actually increase the DS size for that single partition, and then save some time or buy some time, hopefully. Also, the max size, the DS size is 1 terabyte rather than 256 gig, so you can have more space. They were introduced in version 12, but they were really they were optional, I would say, in version 12. The default was the absolute page numbering, the sort of the older one. But then with version 12, with version 13, the relative page numbering is now the default. It is governed by a CPAM, so you can change the default if you like, but unless you do something actively, then you'll get an RPN in version 13. So how do you identify deprecated tables? I found an older iDoc post by Dan Luxetich where he had a query. I made some small adaptations to the query, but it's basically his query. You can run against your catalog tables and figure out how many deprecated objects do I have. And you see the result of the query here on the right-hand side. I've seen some customers that basically turn that into like a dashboard. So you would run this query maybe daily or weekly, and then hopefully over time, the number of deprecated objects should sort of trend towards 0. Ultimately, you probably want to get rid of all of these over time. Also, one thing you might also want to look for is the creation of new deprecated objects. Obviously, it doesn't help if you have DBAs creating new deprecated objects that you then subsequently have to address later on. So you might want to check, have another query that checks for deprecated object that has been created recently, and then educate the DBAs that they should really not create new deprecated objects. So yeah, as mentioned, you can turn this into like a dashboard and then follow the trend over time. So what are the challenges around tablespace types? Obviously, all of these tablespace types, including the simple one, they are still supported. You can have existing tablespaces that are using the deprecated ones. And for many of them, you can actually still create them if you wanted to. So yeah, they are supported, but they are obviously not strategic. IBM has not announced any end of support for any of these tablespace types, so there's no hurry. But eventually, I would assume that they want to get rid of the support. Some of the challenges around some of the older tablespace type would be around size restrictions, locking issues, potentially lower performance for certain operations, and there are probably other things as well. But probably more importantly, I would say, is that most or all new features are only delivered for universal table spaces. So things like clone table, the currently committed, locking, inline lobs, almost all of the pending alters, things like drop column. Some more recent enhancements would be the redirected recovery, key labels for transparent encryption, Huffman compression, etc., etc. All of these are only available for universal table spaces. So if you're using some of the older table spaces, you cannot exploit any of these new features. So that is one advantage of moving forward. Then obviously you can already be on a universal table space, but you made the wrong choice initially. So as of function level 504, the PPG is the default tablespace type. It could have been the default tablespace type on earlier versions and function levels, depending on how you set up your CPAMs. There are CPAMs that governs that. So if somebody just did like a simple create tablespace TS name in DB name, they would get a PPG at 4 or 5 or later, or even a create tablespace TS name, they would get a PPG in the default database. So they're pretty easy to create, and if you don't make a conscious attempt to create one of the other tablespace types, you will get a PPG. In general, PPGs are best suited for relatively small tables, or tables where there's no obvious partitioning key. Also, where you have no need for partition level utilities like loading a partition or reordering a partition. And for that reason, obviously, if you need to reorg that table very often and it's large, it's painful because you have to reorg all of the partitions in the PBG. So if clustering is important, PBG might not be the right choice. Some examples that would be good for PBGs would be write-only tables, like logging tables, or tables that are accessed by transactions only. So what could happen is that when you as a DBA designed a table initially, the developer told you it's going to be a small table, and you trusted him, but now you have 42 partitions at 64 gigabyte, and running utilities and maintaining that table is now painful. All of your indexes on the PBG are NPIs, which is also painful. As mentioned, there's no partition level utility support. You must reorg the entire table space if you want to regain clustering. So it's pretty painful now. And up until DB2 version 13, the only way to move away from the PBG to a PBR would be to unload, drop, create, and load. Obviously, that's not very appealing if you have 42 partitions at 64 gigabyte. This be a very long outage. So for these scenarios, version 13 can really help you for these migrations. So if you want to go strategic, there's now an option for all table space types to go strategic. In this table, I've shown the original table space type, the target table space type, when it became available, and then the sort of the high-level instructions for moving. So the first two that have been around for more than 10 years, since version 10, the migration of classic segmented multi-table table spaces was recently made available in version 12, functional 508, and I'll go more into details on that one. And then the classic partitions has also been available since version 10. So let's look at converting the multi-table table spaces. Previously, the multi-table table spaces were very often used for small tables, maybe in the past to avoid hitting the maximum number of open data sets you can have on a DB2 subsystem. Today, the limit is pretty high for DS Max, so unlikely you'll hit that today. In many cases, they were also used by the tools vendors for their own metadata tables. QMF SAPE data is probably the worst offender in this space. I've seen customers where they have the QMF default table space has like thousands of tables. Today, you can configure QMF to save data into implicit PBGs, but you probably historically has the default table space with thousands of tables. Obviously, if you want to clean that up, it will take some time, and also maybe you would have to do some cleaning up along the way. Many of those old tables are probably not used anymore. I have also seen customers use multi-table table spaces for application tables, small application tables, or even entire applications in a single table space, smaller applications. So functional 508 introduced the pending alter, where you can do an alter table space, move table to table space. It allows you to move the tables. So overall, the process is you have to create a new target table spaces first. Then you issue the alter for each of the tables you want to move. Then you materializing, this is a pending change, pending alter. So you have to materialize it with a reorg. Then optionally, you may want to run stats. I'll have some more details on that. And then business as usual, you want to rebind invalidated packages. And then obviously, if the source table is now empty, you may want to drop it so you don't have an empty table space around. This does require a bit of work, and if you have one of those table spaces with 100 tables inside, you may want to use tooling. So either I've seen customers that have built homegrown solutions for this, or probably your favorite tools vendor will have support for that as well. So The first step is create the target table spaces. Some considerations. The table space must be explicitly defined, so there's no support for implicit table spaces. Also, the table space must be empty because we are going to move a table into it, and there can only be one table in a universal table space. It cannot have log columns, so this might be a restriction for some. It must be in the same database as the source table space, so you can only move tables within the original database. If you have a lot of tables in that database, you might have some run into the limit of available object IDs. So that could be a limitation. In the DB2 manual, there's like a couple of queries you can run to see if that may affect you, but for some it could be an issue. The table space must be defined no, so there's no vSAM cluster created. They must have max partitions 1. The logged attributes and the code page must match the source table space. So you cannot move a Unicode table to a EBDIC table or vice versa. They have to match the code page. Obviously, the table must be large enough. So make sure that you choose a DS size that is large enough. You could use DS size 64 gigs, then you're guaranteed it will fit. But if you want to use something smaller, you'll be aware that it's large enough. You can change the buffer pool if you want. Obviously, the row has to fit within the buffer pool, so you have to consider that. You can change the storage group, and you can change the log size. If you go to IBM's AHA website, where you can log product enhancements, you can find that there are AHA ideas open for most of these restrictions. They affect some customers. That I think there was one for supporting implicit table spaces. I think there was one for lifting the log restriction, but also the one for moving outside the database. So if some of these affect you, you go find the AHA idea and then vote for them, so IBM knows that you're interested. Then you issue the alter table space move table. You have to make sure that there are no other pending changes for the target table spaces. There's one thing that is important here is that the duration of the switch phase will scale linearly with the number of tables being moved. So if you're moving 1,000 table versus 1 table, it will be the switch phase will be 1,000 times longer. So if application availability is important for you, you can consider sort of batching the alters and reorgs. So for instance, you might do 5 alters, move 5 tables, then do a materializing reorg to move those 5 tables. Then you do another 5 alters, then reorg, etc. If obviously now you're trading application availability with the cost of a reorg, but that is one option. Also be aware that the switch phase of a materializing reorg will take longer than a regular normal reorg where there's no materialization, simply because the reorg has to drain more resources when it does the materialization. So it will take longer. You cannot really compare to a regular reorg. So something to consider, especially if these are application tables. If it's a QMF table, it might not be an issue. If it's application tables, it might be. So you might have to batch them up, or you have to schedule it in a maintenance window where it makes sense. Materialize the pending alter for materializing reorg, it has to be a share level change or share level reference. I guess most users are doing share level change reorgs anyway these days, but share level none will not materialize. You have to use fast switch yes. This is the default, so unless you have explicitly coded fast switch no, you should be okay, but be aware. We already discussed the switch phase. One important thing about this particular materialization is that for the inline image copies, you must have a template that uses the table space name or space name variables in the template. This is because we are moving into new table spaces, and we are going to take an image copy for each, so they have to have unique names simply. So you have to use the TS or SN variables. Keep dictionary is ignored. DB2 will not move your dictionary, but it will build a new one in the target table space if the table space is large enough. Statistics is ignored. I'll come back to that on the next slide. There are some optimizations you can do. Use sort device type something which enables parallelism for the unload and reload. You can do sort data no, recluster no, if you don't care about the clustering order. This avoids potentially costly sorting, and you can use fast unload instead of unload from the clustering index. So this is sort of a performance optimization, or you save some sort space. Regarding the run stats, as mentioned, the statistics keyword is ignored on the reorg. So what will happen is that the existing table and index run stats on the tables being moved are untouched, and they will remain. However, your target table spaces were brand new, so they are all initialized with -1 or 0 or whatever the default values for the run stats is. So on the table space level, you will have default statistics. So if the table space statistics are important for your access path, I recommend running a standalone run stats afterwards to get all the run stats updated for the new target table spaces. Yeah, otherwise they are initialized at -1. Rebind the invalidated packages. This is business as usual. I've included here a link to the DB2 manual. It has some queries that help you identify the packages that are affected by this, and you would have to run a rebind for these. Depending on your risk profile, you might want to rebind packets and hope for a new, better access path, or you can use rebind packets access path reuse warn to get a warning about any access paths that might have been changed in the rebind, or even AP reuse error if you want to stop the rebind. So this is business as usual, and if you're using a tool for this, they would normally do this by default. And then finally, if the original source table space is empty, you can drop it. Another strategy would be to move all but one table. Then you have one table left in the original table space, and now you can convert that to a PBD business as usual. So one comment about recovery. It's not possible to recover to a point in time before the materializing reorg of a moved table. It is recommended to take a new full image copy after the materializing reorg. If you're doing a shell change, you will have an inline image copy, this should be fine. But if you're doing shell reference, you might want to take a new full image copy. If you need to recover to a point in time before the materialization, it's going to be ugly. Probably not recommended, but theoretically it should be possible to drop the new table spaces, then recreate the old table spaces, perform some combination of DSN1 copy, some SQL redo or change accumulation using tooling, rebind packages, etc. If I would probably want to test this out in a test system before you would rely on this fallback mechanism, but it's theoretically possible. And just an example showing you how it could be done. So I'm using a tool here. First step would provide some of the options. There's like the naming mask for the target table space. So I'm saying use the 6 first characters of the original table space name, then add like an alphanumeric counter afterwards. I want to have 2 tables per reorg because application outage is important to me. I get the results screen here where it shows that I have 3 new table spaces. Continue, and then on the left-hand side we have the first part of the generated job where we see the creation of the target table spaces, then the move of the first 2, followed by the first materializing reorg, then the move of the remaining table, and then the reorg to materialize that move, and then here's some output. Once you run the also move, you see the SQL code +610, which indicates a pending alter that requires a reorg. I've pasted in here some output from the reorg. I think important part here is that applying the pending definition change is complete, so it has materialized the change. And now if I look at the table spaces in my catalog tool, I can see the original table spaces. This now has 0 tables in it. I have the 3 new target table spaces. Each of them have 1 table, and on the table space type, I can see that the new ones, they are PBGs. So everything worked as it should. So that was the multi-table to PBG. Then let's talk about if you have made the wrong choice. So maybe you started out with a PBR and because you thought it would be a large table, and now it's turned out that it's not actually going to be large, and you have like a small table with 1,000 partitions. You want to change it to a PBG instead, so you don't have all those data sets, etc. So this is not supported by DB2. There is an AHA idea open for that. So if this has interest to you, I would recommend go voting for it. I have a feeling that it's probably not regarded as a big issue because the penalty of have chosen a PBR versus a PBG is much smaller than the opposite. So I would not have my hopes too high for this one. If you want to do that migration, there's no supported way by DB2, so the only solution is the unload, drop, create, load. If it is a small table space, it might be a manageable outage of a couple of minutes, or maybe 20 minutes, 15 minutes, but it will be an application outage. Another scenario where I made a wrong choice would be that the partitioning key was incorrect. So maybe you chose column 1 as the partitioning key, but you actually wanted column 2. Or maybe you want to append a column. So you still want to have column 1 as the leading column, but you want to append a column 2 to the partitioning key. Again, these are not supported by DB2 natively. Again, there's an AHA idea open for that, so go vote for that if that's an issue for you. And the only solution today is unload, drop, create, load, which will probably be painful in this case when you have a large partition table space. But there's no solution today. Then, as mentioned, in version 12, the IBM introduced the relative page numbering PBR or RPN. Some of the advantages of the RPN is that it is strategic. As mentioned, once you are in version 13, RPN will be the default. Some of the advantages is certain partition level attributes like DS size. And I think I've heard IBM mention that they probably want to move other attributes down to the partition level, and they can only do that with the RPNs. It also supports extremely large table spaces. So if you're running out in some of your larger tables, this could be a solution for you. So one thing to note is that there's no migration back from RPN to APN. So the fallback is going to be painful if you need that. You can only move forward, so to say. The overall process, you have to make sure that the table space resides in a storage group with the SMS extended attributes and extended addressability that's required. Then you issue the alt table space based on relative, and then you have to reorg to materialize the changes. So let's look at the stow group first. The table space must reside in the stow group with the extended attributes and extended addressability. There's a couple of ways you can determine that. One option would be to run IDCAM's listcat. So I've done this here on the vsum cluster. Then on the red highlighted at the bottom here, we can see that in the attribute section of that vsum cluster, we can see extended and extended addressability. So this vsum cluster is good, and I could convert that to RPN. You could also, if you check the check the DDL of your stow group for that object. In my case, I have data class db2ea listed for the stow group. And then if I go into the SMS ISPF panels, ISMF option 4, then display that stow group page down a couple of times. Again, we see the attributes of that data class. And we can see that it has the extended attributes and the extended addressability. So again, that's a different way of checking. That's okay. If you're not okay, you have to move the stow group first. Move to the stow group first. And this is a bit interesting. One issue is that you have to stop the tablespace name before you can change the stow group. I think it's probably because of timing issues. They don't want to risk that some dataset operation is happening while you're changing it. So you have to stop it first, then issue the alter, changing the stow group, and then you can start it. So you'll have like a small application outage, a couple of seconds while you run these operations. What I also found interesting is that this does not put your tablespace into advisory reorg pending. So basically, you change the stow group in the DB2 catalog, but it has not been materialized, and there's no sort of external visibility that you need to actually run a reorg. So you have to remember to run a reorg to recreate the data sets in the new stow group with the new SMS attributes. I've seen a couple of customers complain about this, but I don't know if anyone has opened an aha idea on that. So be aware of that move operation, that it requires an outage and that you have to remember to do a reorg. Okay, so once you have your table spaces or partitions are in the right stow group, then you can change it to page stump relative and then run the materializing reorg. As we've seen before, the reorg must be shareable change, shareable reference, fast twist, yes. Some of the similar optimizations can be done, the sort device type and also the sort data no, recluster no. If you really want to optimize, you can also basically dumb down the statistics, run statistics all, sample one, report yes, update none, which will collect as little statistics as possible and then throw it away. But that will save you a bit more CPU if you really want to optimize. If you forgot about the extended attributes and the extended addressability, you'll get a resource unavailable during the reorg with a recent code of D70008. And if you look that up in the manual, it will basically tell you that you forgot about those SMS attributes. If you end up in this scenario, you would have to terminate the utility. Then you would have to drop the pending change for the RPN migration. And then you'd have to go back to the previous slide and move it into another stow group with using the stop, alter, or start. Or alternatively, you would have to work with your storage admin to update SMS for the existing stow group, and then you would have to reorg to pick that up. Then we get into sort of the latest enhancements that came with version 13, which was converting PBGs to PBRs. So this came along in version 13, function level 500. There's now an alter table, alter partitioning that allows you to do that move. So one important point here is that move will move you to the RPN tablespace type. So you cannot convert to the old traditional absolute page numbering. It's only to RPN. Overall, the process is issue the alter, reorg to materializing pending alter, and then rebind the invalidated packages. So they're a similar process as the other materializing reorgs. There are some restrictions, and I'm sorry for the busy slide, but these are some of the more important ones. There are additional ones as well. The table space must be a PBG. Yeah, well, it is a PBG to PBR conversion. However, if you already have a classic segmented, you must convert to a PBG first. Unfortunately, you cannot stack these pending alters. And so you would first have to, if it's classic segmented, you would have to do the alter table space max partitions 1, then run a materializing reorg to convert to PBG first, and then you can add the partitioning to convert it to a PBR. You cannot stack these. There's no support for tables with XML and log columns. That might be a problem for some. There's no support for clones, not support for hash, but they are deprecated anyways. You cannot do it for an accelerated tables. So if your table is accelerated, you would have to remove it from the accelerator, then do the migration and re-add it back to the accelerator. So you would have kind of an accelerated table outage. It would not be available in the accelerator for some period of time. And you cannot do this for the catalog and directory tables, which probably makes sense. In general, you cannot have any unmaterialized changes. However, IBM shipped a APINE a couple of months ago in December, where it does allow you to stack some pending alters. So for the table space, you can change the DS size and buffer pool. You can change the sec size, but excluding the UTS conversion, you cannot stack the UTS conversion. You can also change the member cluster. For the table, you can do an alter column if you have enabled pending alters for columns additions, and you can also stack a drop column. And for the index, you can change buffer pool and compression. So you can stack some pending changes, but not all. The table definition must be complete for the table, so you must have keys, index for primary keys, and so on. When you create the partitioning key, you must use max value for sending keys or min value for descending keys. So that's to make sure that all the data can go into a partition. If you did not use max value, for instance, there might be data that would not fit in any partition. That's probably not good. There are some limitations around data capture changes. I'll get back to that. And then obviously, because we are migrating to an RPN, it must have the extended format and extended addressability. And so going back to the previous slides, if not, you would have to move it to a different stow group or update the SMS attributes and then do a reorg to materialize that change first. Again, it cannot be stacked with the other changes. So there's a new alter syntax, and I think the great design by IBM, the partitioning part is completely identical to the create table syntax. So if you can write a partitioning clause for create index, for create table, you can also write it for the alter table here. So that's great. Alter table, alter partitioning to partition by range, and then the partitioning as business as usual. The word range is optional if you prefer not to type that for whatever reason. I don't know why. Then some other concerns. You can have fewer partitions, and then the materializing reorg will delete the excess partition. The exception is that if your PBG has data capture changes, so if you're replicating this table, for instance, you cannot have fewer partitions. And the reason is around compression dictionaries, which where the RBA is stored in syscopy, and if you drop the excess partitions, you lose the RBA for those, and bad things might happen if you have to for your replication product. So for data capture changes, you have to make sure that you have at least the same number of partitions. You can have more partitions. In that case, reorg will add those with the attributes inherited from the original. And you might carefully want to review the DS size. The new partitions will inherit the old DS size, but depending on your partitioning key, etc., you might have to increase the DS size to have enough space for each partition for all the data. So either you have to carefully create the partition limits so they fit into the existing size, or you have to increase the size if not. With the DB2 APA I mentioned before, you can actually stack the DSS changes along with the PBG to PBR conversion. So you can do that in the same commit scope and same alter, and have everything materialized in a single reorg. The materializing reorg again must be shared with change, shared with reference. It must be a reorg of the entire table space, not on the partition level. Fast switch yes, as we discussed before. Keep dictionary will be ignored, and reorg will build a new dictionary for each partition, assuming there's enough data available in that partition. The sort data no, recluster no trick is not possible here, because reorg has to sort the data to figure out into which partition the data goes. So it has to do the sorting. So even if you put the sort data no, recluster no, I think it'll be ignored, or you might get an error. I'm not 100% sure, but it won't work. I did see a question in the chat.
Yeah, units from Adrian D is sort of a suggestion of another way of kind of moving to a different structure.
Yeah.
Adrian, do you want me to unmute you to ask the question, or you? I'll unmute you actually. There we go.
So yes, it's just to say in the that in the past we've created a new table up front based on the old one, what the old one was, with whatever new attributes we wanted for it. Unloaded the data, loaded it into the new table, and then at that point you've got a decision point. If you're happy with everything, you could go ahead with a rename. So obviously you have to rename your existing table to _old or whatever you want to use, and then we've renamed the new table to the real table name. You do have to drop some stuff to get that through, such as triggers and views and stuff. And there's a process to go through, but I've found that works quite nicely, and I'm quite comfortable with the fact that you don't have to. If you're not happy with anything, you can just get rid of the new table and go again next time when you next have an opportunity to do it.
Yeah, actually, we have a couple of customers that have suggested a different way of doing some of these changes of structures. Because for some customers, the materializing reorg is painful because of the sizes and the amount of sort space needed, etc. And that is actually to do something similar, where you create a new structure under a new name, and then you load the data, and then you would use some kind of log analysis tool to catch up on the log. So you would keep the source table space actually read write. And it's kind of like implementing a reorg, but not in reorg, and then doing sort of replaying SQL on the target table space, then keep reading the log, and then at some point you put the source in read only, you catch up the last part, and then you do the rename to switch back and a rebind. So that would be a way of avoid having to use a lot of sort space and running a costly reorg for these kind of changes. In your case, you'll have a longer application outage, whereas in the enhancement that some have discussed, we could have a much shorter application outage. But obviously, the shortest application outage would be with a reorg, where it would only be the switch space.
Yes, I do quite like the reorg idea. If I presume it'll run share level change when you do all this.
Yeah.
That sounds good, because we are quite lucky that we're still able to have some outage time here to do these things like this. Yeah.
And I guess that also gives you the back out option, doesn't it? And if you don't like it, you can stick with the old one.
Absolutely, that's what I really like. It makes me feel comfortable.
Yeah, it makes sense
when doing stuff like this.
Okay, there's another question actually from Sunil is keep dictionary ignored when a table in non-UTS is converted to UTS PBR?
I believe it's honored in that case. So if you're moving from a classic partition to a UTS PBR, I think pretty sure it's honored. 99%.
Okay, 99%. We'll go with that. Thank you.
All right. So where are we? Okay. Right. So that's the reorg to materialize, and then as we've seen before, rebind any invalidated packages. I forgot to mention earlier on that for most customers they have auto rebind in effect, so DB2 would automatically rebind these later, but there are some drawbacks of using auto rebind. So most customers prefer to explicitly rebind the packages rather than wait for auto rebind. Recovery, point-in-time recovery, just like the previous changes, there's no way to recover to a point in time before the change to this partitioning scheme. Like before, if you run reorg shell of change, you will get an inline image copy, and so you would have a new recovery point, but it's not possible to recover to a point before that. And the possible manual procedure would be to drop and recreate and then use DSN1 copy, log analysis tools, etc. to recover. So the backout plan is pretty complicated for these kind of changes. In the past, IBM has sort of slowly lifted some of these point-in-time recoveries. So initially, some of the first UTS migrations, there was no point-in-time recovery, but there is actually now. So maybe we can hope that in the future that some of these restrictions are lifted for these point-in-time recoveries. But currently, it's not possible. Okay, so I go through a concrete example. So on the left-hand side, I have a DDL for a PPG. A couple of things to note is that the Stoke group here was DB2EA. If you can remember from my earlier slides, that is my storage group with the extended attribute. So I'm good to go from that point of view. Also note that it has sec size 32 and max partition 254. So this is in fact a PPG. So that was also one of the conditions. If the max partitions was missing, then I would have to do the migration to PPG first before I could do the PBR conversion. Then we have DS size 4 gig and num parts 8. So I should be careful when I do the partitioning to make sure that the data actually fits in the new table spaces. On the right-hand side here, we see the real-time stats, and we can see that while it has 8 partitions, it's actually only the first 4 that are any data in, and we can see that the first 3 partitions are actually full. So we have to be careful with the DS size. I could potentially fit this into 4 partitions, but I would have to choose my partitioning keys very, very careful for that to work. And we have to remember to check the data capture changes. Okay, so then we have the table DDL for the existing table. So we note that it has data capture none. So I can choose the number of partitions freely. I can go higher or larger. Then I have to choose a partitioning key. There's really no obvious partitioning key in this specific table. I have this culture column, which is 3,000 characters, so probably not a good choice. There's a date. So I looked into the data in this table, and it turned out that call data was not really a good candidate. It did not really have much variation in that data in the table. So row data, row ID seems to be the best partitioning key. Obviously, an alternative would be to add new columns. So for instance, you could add like a new identity column that is auto-generated. That would not really affect applications, and you would have some kind of partitioning key for that. And if you, as mentioned, if you use you can stack this the also add column along with the PBR conversion if you're have the CPARM switched on where add column becomes a pending order. However, in this case, I'm going with row ID. So I'm using a tool here because my hand coding skills for DDL is not great. It's at the same level as my JCL skills. I cannot write neither DDL nor JCL from scratch. So I'm using a tool here to help me. There's an option to convert to PBR. So I'll choose that. I end up on 10 partitions in this case. Next screen, I select the partitioning key as row ID ascending. And then finally on the third screen, I enter the limit keys. So I did some analysis of the data in my table, and these were the partitioning keys I chose. Note that the last column has to be max value. That's one of the requirements for doing this conversion. And then it generates the DDL for me, so the alter table, alter partitioning, and then a materializing reorg to materialize the new partitions. So I run that job, and now I have my new table. I regenerated the DDL for both the table and the table space. So the table space, you can see that I did not change the DS size, so it's unchanged. I now have 10 partitions as I asked for. And you can also see that it has the page sum relative, as mentioned. We migrated to an RPN table space, so that's all as expected. In the create table clause, we now have the partitioning part in the create table with the partitioning limits that I defined. So it's kind of, it could be important that you ran the alter on the table space, but actually the table DDL is also updated. So if you're keeping track of your DDL in other tools like a Git repository, you actually have to remember to regenerate both and then update both in your DDL archive. And then on the bottom of the screen, I have the real-time stats again, and I can see how data is now distributed across these 10 partitions. The first 8 or so are sort of half full, and not so much in the last ones. So that was my migration here. So and then this interesting point could be going back to the unload scenario, unload load scenario from before. What is the comparison between these two types of way of doing it? You could either implement this through the alter and materializing reorg, or you could do an unload, drop, create, load. So what are the difference actually? So I did a highly unscientific benchmark here. So it's n equal 1. I did one run only. Obviously, your mileage may vary. Blah 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 blah. There's some small text here, total disclaimer of the numbers, just to give you an idea of what you can expect. So I had 15 GB of data in my table. I was using virtual tape for the unload and for the image copies. They obviously slightly slower than DASD. So the reorg elapsed time 3 minutes 22 seconds. Spend a bit of CPU and a bit of zip time. The switch phase in my scenario was 0 seconds. Obviously, my system is a demo system, so I don't really have production workload. So in real life, the switch phase would obviously be longer. So compared to the unload, drop, create, load, again, I have the unload data sets and image copies on virtual tape. Now I have an unload and I have a load. I did not time the drop and create DDL statements. In general, they should be fairly quick. Obviously, if you have a lot of partitions, it will take ZOS some time to scratch the data sets and then create them. But I think it in general be much smaller than the overall time for the unload and load. They would be the most important ones. So I have the total. Then I sort of, for easy comparison, the reorg plus alter took 3 minutes 21 seconds. The unload load was 5 minutes and 12 seconds, so slightly more. In terms of CPU, it was 21 seconds versus 28. However, the reorg did use more SIP versus the unload load. So it depends on how you pay for your cycles, what is best. But I think where the difference really is in the application outage. So for the reorg, also plus reorg, the application outage is really 0 seconds. It's or close to 0. It's very low. In my case, it was 0 seconds because I don't have much workload. In a real production environment, it would be larger, obviously. And the rebinds is kind of an application outage as well, so they should be factored in. Whereas in the unload load scenario, I would have an outage of 5 minutes. In this case, 5 minutes and 12. So it would be much longer. So the biggest advantage for the also reorg here is the application outage. I don't think there's much difference in the CPU and SIP time as such. It's probably smaller. Now this was a 15 gig table. Now if you have 150 gig, you can multiply by 10 on my system here. So we are looking at a 1 hour application outage rather than maybe a couple of seconds. So this is where this procedure has its advantage. Going back to what we discussed before, you could imagine some kind of hybrid where you're doing the unload load and then some kind of log analysis to replay the changes. And in that case, you could probably lower that outage as well. But I don't think there's any tooling support for these kind of things today. So that brings us to the end. I discussed all the universal tablespace migrations with the focus on the more recent ones. Discussed some tricks for the materializing reorg, using sort data no, recluster no, if no sorting is needed. Still have a couple of minutes left for questions, and please go and fill out the session feedback. There's a link here, or you can use the QR code. So any last minute questions?
I think there's a few comments for you, Jorn, but there's no questions that I can see at the moment. But if anybody's got a question, please shout. Well, please shout virtually on the chat, and I'll unmute you.
Yeah, otherwise my email address is on the first slide of the deck. So if you have any questions or any comments here, you can always reach out.
I think we are suffering a few problems with the website at the moment. We've asked the managers to look into it. Okay. Hopefully we'll get that speeded up again shortly. But so do bear with if you're trying to provide the feedback, which we do appreciate, and you can't get through and it's hanging, then please try again later if you can, because we do appreciate all your feedback and helps us to build the conference going forward. Thanks very much, Jorn. I know I found that really useful. And the next session up is at 10:30. It's another Rocket Man. We've got Tom Crocker, who's going to talk about foundation. He says, as he's closed down the website, it's the IBM DB2 Administration Foundation. So it's the next Data Studio stroke DSM delivery from IBM and Rocket. Okay, thanks very much, everyone. Hope to see you soon, and time for a coffee break for 30 minutes, and we'll be back soon. Thanks, everyone.
Thank you.
Thanks, Jorn, of course. Well done. Lovely session. Thanks.